Hi guys, and welcome to another day of factoring. We're going to skip around a little bit in this chapter. Don't worry, it's all going to make sense, but we're going to skip to section 8.8, which is called factoring by grouping. Now, in this class, I'm not going to teach you factoring by grouping. If you'd like to learn, you can look it up in your book, or I believe Delta Math shows examples of how to do factoring by grouping. Instead, since we really focused on using the box method when we did our multiplying out problems, I'm going to focus on the box method for this as well. So I'm going to show you how to use the box method for factoring. On your factoring book, I wrote on my second row right here, box method. And then I wrote the number 4 over here. So these numbers on the side, and this one says all, but this is a number 4. This tells you how many terms you need to have to use this type of factoring. So GCF, greatest common factor, that can be used for any sized problem. Binomial, trinomial, 4 terms, 5 terms, 6 terms, doesn't matter the size. GCF can always be used. But the box method is going to be very specifically for something with 4 terms. So that's what we're going to focus on today, is problems with 4 terms. Once you wrote down your title, go ahead and open up to the box method section. We're going to do a total of 5 examples in this section. So you can do the first 2 across the top and then the last 3 on the bottom. Let's get started with example 1. Again, the box method is used for anything that has 4 or more terms, but we're going to really just stick to 4 terms in this class. Now, we are going to use the same box that we used in the first half of chapter 8. Since there are 4 terms, we need to have a total of 4 inside boxes. Remember that we're working backwards this chapter. This would have been the answer in the first half. And so now it's the question. Since we're working backwards, we're not going to start on the outside of the box. We're actually going to start filling in the box. So if I have 4 terms, I need a total of 4 inside boxes, or a 2 by 2 box. Every problem that uses the box in this chapter will always be a 2 by 2 box, so you can just automatically draw it that size. And again, since we're working backwards, I'm actually going to take each of these terms and I'm going to fill it into the box, starting in the top left-hand corner. So I'll put the 12x to the third, and then next to it, I put the 45x squared. Then I jump down to the second row and I put the 32x. And then I finished it off with the 120. We're going to continue with our topic of greatest common factor. And we're going to really focus on the top 2 boxes to start this. And we need to find the greatest common factor between 12x to the third and 45x squared. For your variables, again, you're going to use the smallest exponent. So I will be taking out an x squared as a common factor. For the numbers, sometimes it'll be obvious. Sometimes it'll be not so obvious. So you might need to make that factor tree again to see what they have in common. 12 and 45, the largest number they have in common is a 3. So 3x squared is my GCF between those 2 boxes. From here, I like to think of this as our multiplication table. So I'm going to focus on the first box. And this 3x squared needs to be multiplied with something up here to create this 12x to the third. So we've got to think 3 times what is 12? And x squared times what will become an x to the third. And that's what we're going to write across the top up here. So across the top, I'm going to write 4x. 3 times 4 is 12. X squared times x is x to the third. Next, we'll look at the next box over. So this was also in the top row. So we have 3x squared times something has to turn into 45x squared. Now I've already got the x squared taken care of, so I will not have an x right here. I just need to figure out 3 times what is 45. If you don't know that off the top of your head, go ahead and divide it on a calculator. 45 divided by 3 is 15. 15 times 3 is 45, and I have my x squared. Let's jump down to that second row. This first box in my second row is 32x. This box is created by multiplying something over here with the 4x from above it. So we need to figure out 4x times what is 32x. I've already gotten my x taken care of. So I just need to remember that 4 times 8 is 32. Now there is a way to check and make sure that you've done all of this correctly, and it's that last box, because we haven't really dealt with the last box yet. So looking at the last box, if I did this correctly, 8 times 15 should equal 120. And I would definitely check that on your calculator. It's a really quick check. 8 times 15 equals, and if it equals 120, we did a good job. We got it right. And if it doesn't equal 120, then you made a mistake somewhere. The first place I would check and make sure you actually took out the greatest common factor over here. That's probably the most common mistake, is maybe you took out a number that was too small. But we did good in this problem. Now for your final answer, you're going to take that from the outsides of the box. And if you remember from last chapter, the outside of the box, those were each their own parentheses. So I'm going to create a parentheses with a 3x squared plus 8, and a second parentheses with a 4x plus 15, and this is my final answer. Remember, we're working backwards in this chapter. So what used to be our question is now our answer. Let's try another one. And again, we're writing this on the top of our factoring book. Again, we'll be creating a 2x2 box so that we can put in the 4 terms in order. They do have to be in order, otherwise it's not going to work. Focusing on my top 2 boxes, for my h's, h to the third and h squared, that's a little bit easier to deal with. So I'm going to take out the h squared. I'm going to write it out in front because those are both in the first row. Now for 18 and 45, again, we need to think of the biggest number that's divisible into both of them. So the biggest number that divides evenly into 18 and 45 is 9. Now, if you only took out a 3, you're going to run into some trouble towards the end of the box. So make sure you're taking out the largest number. All right. 9 times 2 is 18, and h squared times h is h to the third. So I'm going to write a 2h up here. 9 times 5 is 45, and I've already got my h squared. 2 times -4 is -8, and I've already got my h. And then we check. -4 times 5 is -20. We did good. I feel pretty confident, and I'm ready to write my answer now. So my final answer for this problem is 9h squared minus 4 times 2h plus 5. Let's try one more in this video. You can jump down to the bottom space if you need to, for example 3. Again, I'll be writing my 2x2 box and filling it in descending order, just like it was written for standard form. From my top 2 boxes, I can take out a y squared that they have in common. And then 14 and 8, the largest number that divides evenly into both of those is 2. It's not very big. That's okay. It doesn't have to be big. It's just the biggest number from our options. 2 times 7 is 14, and y squared times y is y to the third. 2 times 4 is 8, and I've already got my y squared. Now this is already a 7y, and I've got a 7y up here, so I don't want anything to change, but I do still need to write a number on the outside, so I'm going to be writing the number 1. So if you've already got the entire term taken care of, you can always put a 1 here. And let's finish it off. 1 times 4 is 4. We did good. And so my final answer for this one is 2y squared plus 1, and then 7y plus 4. This concludes our first video for today.